Hi guys, this is Jeffrey, and today we're looking at binomial theorem. So binomial theorem is a theorem that entails an a plus b term that to the power of n, right? So you can see here a plus b to the power of n, and that relates to our series, right? Because you have a summation that equals to a summation notation, and where you plug in your numbers here, k all the way to your n, right? And your formula will be looking like this: a to the power of n minus k and b to the power of k. And you have a coefficient in the front, which is your choosing formula, all right? Your choosing formula. Okay, so you choose k from n. You choose k from n, and it will look like this. But if you look onto your calculator, you'll see there's a c, and right beside it is n, right? And k. And you can use that to quickly find out your coefficient in the front. So when you plug it in, here's a quick trick right here. So you write your 4. If let's say your n is 4, so you write first a from 4 all the way to 1, all the way to 0 actually. So anything that is power to 0 is 1, right? So you don't have to worry about that. But do it anyway, right? Write it down clearly, 4 to 0, right? Because your k starts from 0. And from there, you will see b from right to left. So we were doing left to right normally as we write formula, right? But then you can write it back from b to the power of 4 because our n is 4, and all the way back 4, 3, 2, 1, and 0, b to the power of 0, right? And then you're done with your a plus b term. These two terms, you're done with that, okay? But you're now dealing with your coefficient of choosing, right? The choosing coefficient. So now you use 4 choose 0, for choose 0 out of 4, 1 out of 4, and 2 out of 4, all the way to 4 out of 4, right? And then you will find out, use your calculator, and you'll find out your coefficients, okay? So let's look at Pascal's triangle. So I'm sure you've seen this triangle before.
Have this figured out.
Okay, so this will be your first degree. 0 degree actually. We start from 0 degree, and that will be your first degree. That corresponds to the degree or the level that you are doing your binomial expansion on, right? So that's for instance, what we have here is a 4th degree, right? Then you choose your 4th level on your Pascal's triangle. But what is Pascal's triangle? It is just 1, and you expand it to 1 and 1, and then you expand it again, 1 and plus it together. 1 plus 1 is 2, and we extend the 1 to here, right? So we have extended 1 on our sides of our triangle, right? 2 sides actually to our triangle. But underneath it, we just add the numbers together in between, right? So 1 plus 2 is 3, 2 plus 1 is 3. You can do it simply on a test where you have, if you have a 5th degree, where the question is asking you about a plus b to the power of 5, what would you have? You will have 1, right, extended to the side, and 1 plus 4 is the term right here, and 4 plus 6 is 10, and then 6 plus 4 again is the other term, and then 4 plus 1, right? Okay, so we were doing binomial theorem, okay? So basically, you have the term here, 2 terms, a and b. And you plug into, the question is asking you, if you can see here, the question is asking you about x to the power of 6 and y to the power of 6, right? Let me just expand it. So x to the power of 6 and y to the power of 6, and the question is asking you about the coefficient, right? Okay, so what is the fifth degree? So we were doing fifth degree. What is our the choosing formula for our coefficient? You can look at that on your Pascal's triangle. That will be 1, 5, 10, 10, 5, and 1, right? There's a symmetry right in the middle, right? So your this is too slow here. You just use your binomial, your Pascal's triangle. You'll find out it's 1, 5, 10, 10, and 5, and 1, right? You don't have time for doing this, even using the calculator. It would take too much time, right? And then you plug in your A and B, right? Your A and B. You can sort of look down right away, look it up here right away. It complements each other, right? So 2 will corresponds to the 3 that makes up the 6, and 3 will with the 2 for the outside brackets, the degree outside brackets, and that will make up another 6 for your y, right? So this will make up to the y. This is your A, right? This will make up to the y. When you write your A all the way down from 5, 4, 3, 2, 1 here, right? And then from there you have 5, 4, 3, 2, 1, 0 for your B as well, right? But you sort of see it here right away when it complements each other, right? The inside power complement the outside power, which makes up the 6, and the other 6 as well, right? The x, the 6, and y, the 6. So you just have to figure out the middle part of your coefficient for the third term, right? This is 1, 2, 3, the third term of your the coefficient of your third term. And now you'll see using because this is 10, right? And 3 to the power of 3 is 27. So 10 times 27, and 6 to the power of 2 is 36, and that ends up with 9,720, right? 9,720. We don't have to go over that. Okay, so now we move on to our trick, a small trick for when we are doing our expanding binomials with Pascal's triangle. So you can see here, this is x plus y to the power of 7. So right away in your Pascal triangle, you are doing your the number 7 level, right? Okay, so in the number 7 level, you still need to do. You can write out your in the test. You can write out your triangle, one level by one level, right? But there's a little trick here where you write out all the term. Of course, you'll start from your A or your X here, right? So x to the power 7, 6, 5, 4, 3, 2, 1, all the way down to 0. And from there you have 7, right? 6, 5, 4, 3, 2, 1 for your y, to 0 for your y. So you end up with 8 terms, right? 8 terms, okay? So how do we get, without using the Pascal triangle, right? It is saying without, right? Without using the Pascal triangle, how would you know about your coefficient or the choosing formula right in front of your x and y, right? Or your variables, right? So the thing is, you use the 1, right? You can see the color coding here. you use the 1 times the because our Pascal triangle on the two sides, you will have just 1, right? So that's why you have a 1 here for your first term, right? And then you times it by your degree for your first term. Okay, so that the highest degree for your first term is 7. Okay, and for your x, actually for your a, okay, so 1 times 7, you end up with 7 times 1, right? Divide by the first term. Okay, same thing goes to here. You have 7, right? Because this ends up with 7, the purple 7 here with your new coefficient, and then 7 times 6 is your next one, right? So we're just pushing our little formula here to find out the next term's coefficient. Okay, so 6 times 7 will divide by the second term, which is 2, right? So 6 times 7 divided by 2 is 21, and all the way down to number 4, you end up with 35. Okay, but you have a symmetry here, so we don't have to do the other half. So now you can just 35, 21, 7, and 1, right? Okay, so that is our little formula there, and you can apply that when you are tired of using Pascal triangle, right? Okay, so this is explaining why we are using the choosing, right? The choosing formula, right? Choosing 1 out of 3, choosing 0 out of 3, right? Why is that? So
what I want to do in this video.
So you have x plus y to the power of 3, and so you have 3 x plus y, times it together, right? So you have 3 y's to choose from, so that's why you are using 3 choosing. For our first, we don't choose any for our first term, right? Because that belongs to the x, so we are choosing nothing, right? And for our second term, we are choosing 1, right? So you have 3 choices, pretty easy. How about 3 choosing 2? How many is that, right? That is still 3 choices, right? And 3 choosing 3, that is only, you end up with just 1 pattern or just 1 choice, right? Okay, so that will be it. It is basically explaining the same thing here. So we will end our video here. So that will be our binomial expansion here, and using Pascal triangle, or you can use the little trick that we just talked about, and for your coefficients. Okay.